Today's conversation will cover the cost comparisons for devices for remote assistance for frontline workers, including RealWear's HMT-1 hands-free head-mounted tablet. Since this was quite a robust research paper that was developed by VDC, we've asked David Krebs, who's the EVP of Enterprise Mobility and Connected Worker at VDC Research, to personally provide a summary and point of view on the data. We encourage any and all questions. The research comparisons show RealWear as the clear choice for hands-free remote solutions for the front line. We will kick off with a few opening remarks about the company from our president and co-founder, Sanjay Jawar, and then pass the baton over to David. Thank you again for your time today.
Thank you, Megan. It's great to have you with us, and I'm pleased to be able to present the first part of this webinar today. Let me begin by introducing RealWear. RealWear is the industry-leading hands-free wearable solution head-mounted device company, specifically targeting frontline workers with a platform that allows them to connect to the information they need to enhance job performance and improve business outcomes. Now it's my great pleasure to introduce David Krebs, Executive Vice President at VDC Research, where he's been for almost 24 years. Focusing on enterprise and government mobility solutions. David is a true expert in the space of rugged computing as used by enterprises in all form factors, from handhelds to tablets to laptops and other computing form factors, and now, of course, hands-free devices. Over to you, David.
Great, thank you, Sanjay, and thanks to the RealWear team for inviting me here today to share some of our views on this interesting topic around total cost of ownership. VDC Research certainly has a fair amount of experience and background in covering enterprise mobility solutions and really looking at what the true total cost of ownership is of these solutions. So maybe just a little bit of background on VDC Research and also on the content that I'm going to be sharing and referencing today. First of all, VDC is a privately held technology advisory firm. I'm responsible for managing our enterprise mobility practice, and what we really spend most of our time doing in this practice and what we spend most of our time covering is really looking at the intersection of the frontline mobile workforce, or what we define as the frontline mobile workforce, and digital or mobile tools that they're being equipped with to be more productive, to collaborate better, to provide better service, engage better with customers. And that frontline workforce is, really everyone from service technicians out in the field to delivery drivers to retail associates to healthcare workers to first responders. Essentially, the sort of the business critical or the mission critical workforce that really relies on access to information in real time to be able to make important decisions, when and where they need to. So with that in mind, we've been working with the RealWear team over the course of the past, really, in depth over the past year and a half, but really over the past couple of years since they first launched the HMT-1, and really looking at the sort of the use case for a device such as the HMT-1 and the benefits that it provides to its target users, both in terms of workflow productivity and worker safety, but also when looked at from a financial standpoint, from a cost of ownership standpoint. So to support this engagement, we spent a fair amount of time with the RealWear team, first of all, interviewing RealWear executives across a number of different functional departments, including the service team, including the sales and business development team, as well as the R&D teams, to really understand sort of their vision and what they were doing to support their client base. In addition to that, we spent some time with some of their leading customers to really understand what they've gone through and how they've benefited from and deployed the RealWear solution in terms of different use cases. So those spanned multiple different industries and also customers across the globe. And then we complemented that with research that we have done on an ongoing basis over the past couple of years around enterprise mobility, cost of ownership. So we field a survey amongst decision makers to really understand what they're deploying, what their experience is, what the failure rates of various types of devices that they're using, what type of support infrastructure they have in place to really understand not only what it costs to purchase and deploy a mobile solution for frontline workers, but then what the real sort of ongoing life cycles costs are, support costs are, impact of downtime when devices and solutions aren't working properly. So starting high level, I guess one of the most important sort of considerations is that there really is no perfect mobile device for that can canvas or support every type of application and workflow. And while that seems like a fairly intuitive and an obvious statement, it still holds true in terms of how we've seen organizations go about making mobile device investment or selection decisions. Because the flip side of that is, if the wrong device, if you will, is put in the hands of frontline workers, it can lead to a number of different sort of negative outcomes. First of all, the device might not hold up in terms of the environment it's exposed to, so incurring frequent failures. The device might not sort of meet user requirements based on the application or the workflow that they're supporting, which can cause significant frustration and lack of sort of confidence in the tools that are being provided to frontline workers. And I guess the most frequent example of this that we've seen is the ubiquity, certainly, of smartphone technology and the advances that we've seen in smartphone technology for everyday use have made this device an obvious choice for a lot of organizations supporting their frontline workforce. And while the smartphone is certainly, or the consumer smartphone is certainly a suitable device for a number of different applications, including sort of everyday horizontal sort of communication type applications, when put into sort of extreme environments, in particular environments where inclement conditions come into play, when put into environments where the user will frequently need to take that device in and out of their pockets because they need sort of access to their hands to do their jobs. It can disrupt and it can create certainly a negative sort of a negative experience. In addition to the fact that these are intended as consumer devices, and when we're looking at sort of the pace of change and the life cycle of an average consumer smartphone, it tends to be closer to 12 to 18, perhaps 24 months. But when used in a sort of line of business use case or a frontline mobile use case, it just doesn't really align. So when you're thinking about the variety of accessories and support infrastructure, we want to make sure that what we're investing in today is still current and is still supported 24, 36, perhaps even 48 months down the road. But in looking at sort of the frequent change that is happening to consumer technology and what is supported and how long it's supported, be it OS changes, be it sort of accessory changes, a lot of times there just really isn't a lot of, or there can't be a lot of confidence in, that in something that's deployed today will be supported, in 2, 3, or even 4 years down the road. So I think that life cycle is often ill-suited to support line of business mobile applications, no matter how ubiquitous and how familiar sort of workers are with that technology. That's certainly one of the pitfalls that we've seen in a number of different line scenarios. And really what this boils down to is, again, sort of really uncovering and looking, much more closely at that, complete life cycle, from, deployment to, to end of life and renewal. And that has to do with, obviously the cost of ownership of this solution. And I think the iceberg is oftentimes a sort of a great sort of visualization of cost of ownership, because, it can be, and this is probably oversimplifying it a little bit, but when thinking about cost of ownership, there essentially are hard costs that tend to be very tangible and visible, and soft costs that are oftentimes, a little bit more difficult to calculate. And the hard cost being obviously the acquisition of the device, of the mobile hardware, and any sort of application software and connectivity subscriptions associated with that, as well as sort of mobile solution deployment and systems integration. So get everything, to get a solution up and running. But then once it's deployed, we obviously also have to think about supporting that user, that device. So traditional IT support and help desk support capabilities is obviously often associated with that, and that's a fairly basic or a fairly standard, service that is provided, by organizations. But the more challenging aspects of cost of ownership, but also, the potentially more, impactful and detrimental aspects is, the costs associated with when devices aren't working properly, and when devices sort of fail in the field. And this is another, sort of point that I think is important to make, that just like there isn't a perfect device for every, possible use case, there is also no device that will avoid, some type of failure across, across its life cycle, no matter how rugged or how well designed a device is. At some point, the device won't be working properly. So the challenge is, and the key requirement is to balance and to minimize that failure as best possible, and to obviously optimize uptime, of the solution. Hence, or as a result, reducing overall cost of ownership. So it's really a factor of, what happens when a device does not work, properly. How quickly can that, that issue be diagnosed? How quickly can it be addressed? And how quickly can the user or the worker, get back to, sort of doing their jobs? And these are jobs that, where they really rely on these devices to work properly. So that's always been and will be a key factor looking at cost of ownership, because our research has shown each failure incident, and that can be hardware failure, that can be software failure, that can be connectivity failure, results in approximately 17 minutes of lost productivity for the worker. So let's let that sink in for a second. So imagine a workday and a shift of 8 hours. If the device goes down and that worker relies on that device to get access to maybe schematics about a particular asset, or directions, in terms of where to go next, or customer history information. If they don't have that, they effectively can't do their jobs, or at least can't do their jobs well. Oftentimes there's some paper-based or manual backup. But ultimately what happens is you're losing off the bat just over an hour or an hour and 10 minutes of productivity. If that happens once over the course of a year, so be it. I mean, it really isn't obviously at the end of the day that consequential. But if it happens frequently, not only are you dealing with lost productivity, but you're also increasingly going to be dealing with an increasingly frustrated workforce that will come to. These are many of the scenarios that we found organizations run into. And again, just to boil it down into what I think is sometimes a very easy way of looking at things, when you're thinking about failure and its sort of correlation to cost of ownership, what we found that each percent increase, or percentage point rather, increase in device failure typically equates into a 5% increase in total cost of ownership. So that that factor of 5 can, very quickly start to snowball and start to have, a very real impact on, on support costs and an overall cost. So, put this in a different way. We did compare, again, going back to the research that we conducted. We did compare sort of the cost of ownership and the annual failure rates of the RealWear HMT-1, and compared it to a number of different device classes. And in this case, we're comparing it to rugged handheld computers as well as smartphones. And what we found is that rugged handheld computers, on average, and this is over the course of a 5-year life cycle, will have about a 4.5% annual failure rate. So again, fairly low, but again, also not zero. Whereas smartphones, when used, I just want to make this perfectly clear. This is not overall or every type of use case for smartphones. This is smartphones when used in frontline line of business use cases. We'll generally have a failure rate of about 12.7%. So, roughly 3 times the failure rate of a rugged handheld computer. Whereas the RealWear HMT-1 had a failure rate of about 1%. So, into a very favorable cost of ownership for these target applications. So now looking just maybe a little bit closer at, these points of failure, and I think really what this illustrates is it's not just a cracked display or a damaged I/O port or a damaged peripheral. There are, certainly software-related issues, network connectivity-related issues that contribute to a solution not working properly. So it's important to think about the mobile solution, comprehensively, and to understand, how well, my application is integrating and is performing on this particular device. RealWear's, especially with their integration of Microsoft applications, they've done a really strong, really a lot of strong work there. The integration of connectivity or Wi-Fi connectivity on the device has been, also, designed to withstand and perform in again these challenging target environments. Another one that does come up, and I would have thought would have come up more frequently in the research is battery failure. These are devices that are relied upon to work a full shift, and when a battery doesn't hold a charge well, and we certainly see that perhaps not in year 1, but certainly once it gets into year 2 and beyond, that batteries are just not holding up, and we've seen the frequency at which batteries don't hold up, especially in consumer devices, which mostly don't have the option to have a replaceable battery, is again a massive a massive consideration. Certainly, a lot of times you have access to charging, and now we have fast charging capabilities, and that does alleviate some of that. But oftentimes, or sometimes, you don't. And so, if I can't rely on a battery to last a full shift, and it can't hold a charge like it did when I got it out of the box, that also causes a fair amount of disruption for these workflows. So that's also something that is important to address, and I think is something that we've seen the RealWear solution HMT-1 do a good job at addressing. Here going back to again what makes the right device for the right application. I mean, there are so many different considerations that need to be accounted for, and certainly in looking at the research that we've done on this, hardware reliability and durability at the end of the day is probably where a lot of organizations start. How reliable, how durable is this device given sort of the environments that I'm deploying it to? Ease of use is a massive one. A lot of these workers in at least some of these environments, there's a certain amount of turnover. So onboarding and training is critical, and how intuitive and how easy it is to pick up and use a solution, especially a solution that might not, such as the HMT-1, that you wouldn't necessarily be using on an everyday basis. It's extremely important, to ensure that while training is always required, that the solution almost trains itself, or is designed to be so intuitive that it's once it's used, it's clear, and so that's another critical aspect. Obviously, the cost of adoption is always one that organizations, just because it's so easy to evaluate. But again, the one caution we would have is to balance cost of adoption with, again, sort of the cost of support over the life cycle of the solution. And then there's a variety of other capabilities. Do I need to do data capture? Do I need to stream video? What type of or how noisy is the environment that I'm working in? Again, this is something that, especially since, users of the HMT-1 are using devices or are working in environments where oftentimes it's quite noisy. So noise reduction capabilities is extremely important. And noise cancellation. So again, something that maybe one wouldn't necessarily think about, but with a consumer device, just not being able to have the same level of sort of fidelity and noise, audio quality can certainly create challenges. And then finally, the notion of going back to batteries again, sort of having replaceable batteries. This is, as we all know, with consumer devices, increasingly not an option. But if we're using the device frequently, if we're using it across multiple shifts, the ability to easily replace a battery with a new charged one is often a benefit that is critical for these enterprise applications. So just to illustrate some of these points, I did want to provide a little bit of feedback that we got from some of the customers, some of the RealWear customers that we had the opportunity to chat with. And one of them was Group Renault. So what they were, and this was in the UK and Ireland, where they were sort of field testing the HMT-1 for their service techs. So, first of all, the quote, I think, speaks for itself, but, it really talks about, this is a device that's used for, or it's intended for, industrial applications. So when compared to, in this case, sort of more consumer-ish oriented smart glasses, they felt, according to this customer, they felt flimsy and wouldn't last long in a workshop. So this was sort of, this determination was based on appearance, but then they went and tested the RealWear device, the HMT device, and they found that this proved accurate sort of in the field as well when they were testing. And really what the benefit for them, just looking a little bit at the use case, was really about asset uptime. So in this case, so their truck fleets. So when a truck does, much like when a device goes down, you want to make sure you can address it, quickly, so you can get it up and running. In their case, when the truck goes down or has a service requirement or a service issue, we want to make sure that that truck is getting put back on the road as quickly as possible, and that means being able to diagnose the issue quickly, and being able to do it in a very sort of productive way. So what they ended up doing is deploying the RealWear devices, and they found a couple of key sort of benefits come out of their solution. One is they saw about a 5 times or a reduction of in-person warranty parts inspections. So the process was just that much more efficient. And they were able to reduce through remote assist capabilities. They really were able to reduce what was sometimes a 24 to 48 hours of just idle or standing time. That was reduced to about 20 to 30 minutes. So, I mean, pretty remarkable turnaround just in terms of productivity efficiencies that they were able to realize with this another point, and Sanjay had sort of alluded to this capability earlier on, but we're dealing with mobile assets that are distributed or deployed in a very distributed fashion, a very remote or mobile fashion. And so it's critical to be able to manage them, to have some kind of a remote control and visibility into them once they've been deployed in the field. And today, most mobile solutions or enterprise mobility deployments rely on or are using some type of mobile device management, enterprise mobility management, unified endpoint management, whatever whatever term you want to use to describe it, to manage their mobile fleets, to manage their mobile assets. And really what this enables, and again, the statistics certainly bear fruit, is first of all in deployment speed. So provisioning devices out of the box, we've seen massive reductions in time. So about 50%, 56% increase in mobile device and application deployment speed. We've seen a significant increase in the ability to remotely diagnose and oftentimes fix devices. So if I can, as a admin, access a device and be able to figure out, is it a software config issue, maybe network settings need to be addressed. Not having to send the device into a service depot is a massive benefit, obviously. And then there's the NTF issue, the no trouble found issue. Oftentimes, when devices are sent into a service depot, they, as they're diagnosed, they realize, oh, there's really nothing wrong with this. So that's a massive waste in time, a massive waste in cost, and being able to reduce that, being able to minimize that, to as low to zero as possible is obviously the goal of any service organization. So we've seen, certainly key benefits there. And then overall, just time to fix a mobile solution, including, things like software reload. We've seen a sort of a key benefit there. So there's a very close correlation to to be able to manage large fleets of mobile devices in a very efficient, in a very sort of remote manner using modern EMM tools. So looking at again from a pure cost of ownership perspective here. The blue indicating sort of device acquisition and deployment, and the sort of the mustard color indicating the operational or the post-deployment costs, including productivity loss and IT support. So the clear thing that you see off the bat is, and this is over a 5-year period, including upgrades, is the RealWear device, when compared to a rugged handheld computer or an unrugged smartphone, obviously has the largest upfront costs. Not by a massive amount, but certainly by a noticeable amount. And for organizations making capital investments, I mean, that's certainly something that that is going to garner attention. Is how much is it costing me out of the box, or upfront to get these devices in the hands of my workers. Yet on the flip side, and this is really going back to sort of the differences that we saw in failure rates, once deployed, support costs and operational costs are drastically lower to certainly rugged non-rugged smartphones, but also non-rugged handheld computers. And so that's really where the benefits show up. So the ability to consistently have a device operating as advertised, not only in sort of day one, but also on day 500 or day 1000, really reduces that cost of ownership significantly, and translates into in this case a much more economically attractive proposition. So just, I guess, another quote from, in this case, Honeywell, obviously a brand that doesn't need any introduction, or a company that doesn't really need any introduction. So they're using the RealWear devices in a field service scenario, and the interesting part of this quote was, they had previously been using a smartphone, and certainly, technically speaking, what I'm doing with the RealWear device can be done with other devices. I can use my smartphone, and one of the primary applications that we saw, customers of the HMT-1 use the device for was remote assist. So I can take pictures or do video calls with a smartphone. But again, having something where worker requires on their hands to do their jobs, having something that is as seamless as the HMT-1, where I don't, where I'm truly hands-free, and still have access to information, still am able to communicate with a remote expert, still am able to effectively diagnose problems and address whatever service scenario that I'm being exposed to, is really what sets the device apart when compared to, in this case, something like a smartphone that, again, technically can do what the HMT is doing, but just not in nearly as seamless a way as was experienced with the HMT-1. So in that case, that led this individual, who's the manager of digital transformation and workforce transformation, to make the claim that there really wasn't any true competition to the RealWear solution, based on what they were supporting and what they were. So again, I just to reiterate what we have shared and sort of reemphasize these points. It's important to select the right device for the right workflow. So I don't want the impression to be that, again, I'm saying the HMT-1 is far and away better than a rugged handheld device or even a smartphone for every possible scenario. The HMT-1 certainly occupies a very unique segment in the market, and addresses the need of what has largely been, I guess, even an underserved segment of the population of the workforce. And it allows that workforce to leverage this device to be more efficient in the field, and really where there is true benefits for hands-free. And that has primarily shown up in sort of remote assist type applications, but we're seeing certainly applications proliferating beyond that. But the real point here is make sure that what I need is and what the environment and the conditions and the use case and the workflow is aligned with the right mobile solution. So that's certainly point number one. Fundamentally, the key is obviously to deploy a solution that has as little disruption, or introduces as little disruption to the workflow, and is as intuitive and easy to use by the worker. So minimizing support costs, minimizing the cost of disruption, and sort of maximizing mobile solution reliability and uptime. And doing that, it's not just about day one. It's really about doing that consistently over the life cycle. And for these line of business use cases, those life cycles tend to range, I would say, at the low end 36 months, but at the high end sometimes certainly 48, if not 60, if not 72 months. So life cycle consistency is everything. They need to work as advertised on day 1,000, just as they do on day 1. So that's certainly critical. That has been what we found. Obviously, this is a relatively speaking, newer space of the mobile market, the wearable segment, or particularly the head mounted or head worn, wearable segment. But what we have found with the HMT-1 and the HMT-1Z1 is that it struck I think a very good balance between sort of design and ergonomics and protection, and sort of capabilities and intuitiveness of the capability. Clearly, wearing a device on one's head, or being attached to a hard hat or some other type of a head-mounted configuration, takes some getting used to, for sure. But what we've found is the design of this product, and not only from a hardware design, but also from a user interface and the integration of voice prompts and the sort of the quality of the display and the ability to get information has certainly struck a good balance. So what we saw in the research was the 5-year cost of ownership of the HMT-1 is around $5,300, which was roughly 70% less than non-rugged smartphones and 44% less than rugged handheld computers for these specific workflows. Again, just to reiterate that point, not for every application. And for the HMT-1, that primarily has been so far remote assist, but increasingly we're seeing applications such as IoT data visualization, even picking applications in warehouse environments that offer sort of real hands-free operations. So we're starting to see those applications proliferate as well beyond sort of the lower hanging fruit that remote assist has provided. So with that comes to the conclusion of my segment. I'm going to turn it back over now for, I believe we have some time for Q&A with myself and Sanjay. Thank you very much.
Okay, great. Thank you, David. Before we start the Q&A, I wanted to highlight that it's not just one industry that is deploying our devices, and this is because of the need for remote expert is very broad and deep. And we've seen significant uptake in all of these major sectors that are highlighted on the slide, with an incredible acceleration beginning in the last year. And we're seeing it continue in the early part of 2021 so far. Just this week, we announced that we now have over 3,000 unique enterprise customers and that we tripled our year-over-year revenue in 2020. And we're now deepening our footprint in the Middle East, opening a demo experience center to meet demands for our products and our services. You can see all the highlights of some of the customers that we partner with on the screen. So this concludes our content. Thank you so much for attending. I know there's been a lot of activity in the chat about getting a follow-up, either recording of this webinar or a summary report. We will be emailing all the attendees a copy of the complete study, or you can access it on the URL that's on this screen. But if you don't want to, copy that or write it down, we will be emailing it to you. And we're also happy to provide a demo to anyone interested. We'll drop the demo link into the chat, so you can follow up after, or you can put your name in the chat, and we will send you a demo request. So now we're going to move to the Q&A section of the webinar. So let's start off with a few questions that I've seen coming through. So I know there was reference to battery life as one of the factors that was evaluated. What is the battery life on a RealWear HMT-1?
Yeah, great question, Megan. So of course, the battery life does depend on the use case. and the applications that are in use. But what we typically see with a mixed user profile of some remote video collaboration, some document access, some work order management applications, variety of typical applications, is we typically see more than a full shift of real world battery life. So that's 8 to 10 hours. Some customers get 2 days, depending on what they're doing. Video is certainly the thing that uses the most battery. And if you do a continuous video application until the battery dies, and that's all you do, then the leading video applications which have optimized their power consumption are getting around 5 to 5.5 hours on a single battery. Very few customers we have found actually need 5 hours of video calls in a single day. So typical is more like a couple of hours.
Okay, great. There was another question that came up. How easy is it to integrate third-party software into RealWear products? Sanjay, that's a good one for you.
Very good question. So first of all, there are a lot of existing third-party software applications that are already certified and have been integrated, over 200, and all from all around the world. But there is a process for a new application developer to work with the HMT-1. We have the underlying application doesn't need to be fundamentally re-engineered, and the developer doesn't really need to know anything about voice recognition, for example. Most of that is handled by our operating system. So we have a series of tools that developers can use, both no-code tools and embedded code that can be added to applications. We have RealWear Academy, which is our training offering for developers, which we run several times per year online, and it's about 7 to 8 hours of training content split over typically 3 days. And we have a website, developer.realwear.com, which is the place to get all the developer information. So pretty easy for an existing Android developer, or for that matter, someone using HTML5 or Xamarin or Cordova or Unity to adapt their application for an HMT-1.
Okay, great. So how does the RealWear device hold up in dangerous or loud environments? Can you explain how this device was designed?
Yes, so it was purpose designed for loud environments. So indeed, the whole challenge with a voice recognition interface for industrial use is noise. And that is that's an area in which the RealWear HMT-1, HMT-1Z1 are still unmatched over the last 4 years. So there are multiple microphones. There's proprietary noise cancellation. There's more than one algorithm at work for noise cancellation. There's the speech recognition system itself is command-based. So rather than sort of natural language, it's really listening for specific commands on specific screens. Those can change screen to screen, so it can feel very fluid, but it does improve the ability to recognize the correct commands without a wake-up word, without saying Alexa or Hey Cortana or Hey Google, just being able to say the word very fluidly and have it be recognized in noise. So the performance that we get is 97 or 98% voice recognition accuracy in 95 decibels of ambient noise, and even up to 100 decibels of ambient noise, we're still getting 90+% voice recognition rate. And when it fails, it means that you just have to say the word again. So it's it doesn't hear you the first time, say it again. Almost always the second time you say it, it'll hear you. So users have reported that that's really makes the device very usable in loud industrial environments, and one of the real differences with this type of device.
Okay, great. Yeah, and there's support for that in the chat, saying that in a loud environment that they have proof for someone who's been using it, which is great. So Sanjay, when is the next OS release available? Example, image stabilization. And then how do you address challenges with live video transmission due to high bandwidth issues? So could you address some of those questions?
Yeah, so the when is the next release available? Our release 12, which moves to Android version 10 and introduces some cool new features like best-in-class image stabilization for video calls and a number of other things, is any day now. It's the 18th. I think it's maybe next week. Maybe Carl Furlick can confirm that. So any day now. Sorry, the second question was, remind me?
Oh, sorry.
It's about low bandwidth,
Low bandwidth.
environments and restrictions and streaming. We had some questions around that, around satellite communications, what's been done in that respect, and just reliability and any requirements for up and down speeds for the HMT-1 specifically.
Yeah, so of course this does depend on the application. Not all video applications behave the same. It depends on the video codec in use. Some applications have proprietary video codecs that work extremely well in low bandwidth, even over satellite links down at 128 kilobits per second, or we've seen with some applications, not high quality video, but usable video, even below 100 kilobits per second. But generally speaking, for the mainstream applications like Microsoft Teams or Zoom or WebEx, those applications need 500, 600 kilobits of bandwidth. But some of the more specific applications do work down in the low hundreds of kilobits per second. And the codecs make a difference. You know, there's at least one application provider out there that supports H.265, which is a more efficient codec. Most of them are using VP8, VP9, or H.264, and the vast majority of our applications of the HMT-1, I think, are using either VP8 or H.264. There are differences between codecs. The application vendor can also advise you on that, or our solutions engineering team can. We do have customers out in the North Sea using VSAT satellite links with one of our partner applications successfully to stream video. It's also been done in remote mining and other places. So a little more specialist considerations, but does work.
And just to chime in real quick, the general availability of release 12, which will include image stabilization, all those features Sanjay alluded to, is scheduled for March 22nd. So this coming week, that will be available via the wireless update application.
Thanks, Carl. Yeah, 4 days from now. And the HMT-1Z1 version of that, I think, is about 3 weeks later. Is that right, Carl?
Yep, generally about 3 weeks beyond that is when the Z1 release will come out. I will confirm the date.
Yeah. Lots of questions coming in.
Following up on the HMT-1Z1 that you just mentioned, can it be used in a confined space such as a tank? Is it equipped with a light?
It's equipped with a light. However, in a confined space, depending on your jurisdiction and your local safety regulations in the country that you're in, you may need what's called ATEX Zone 0. So the HMT-1Z1 is not an ATEX Zone 0 product. It is a Zone 1 product. In fact, it's the only Zone 1 product in the head-mounted device space that exists anywhere, despite what you may have heard around the industry. And it's certified in 50 plus countries for the intrinsically safe. So that depends on your local jurisdiction and your local safety requirements. And you should talk to your safety representative at your company for more details. But it's rated for ATEX Zone 1, FMC1D1 in the United States, and can also be used, of course, in all Zone 2 environments, which are less stringent. But it is not a Zone 0 device. As far as I'm aware, there is only one computing device certified for Zone 0, and it's a rugged tablet made by GTAC.
Great. Okay. Someone asked, what would be the best application for the best video quality?
Oh, well, we have so many of our partners that are probably on this call. So I am not going to crown one of them as the best. They're all great for different reasons. I think the best thing to do is to really work with our solutions engineering team and customer success team. Carl Furlick is here on the call. He's our head of customer success. And have a conversation about what you're really trying to achieve. What is your local environment? What features do you need? What bandwidth do you have? What's the actual scenario? And our team has experience with 50 plus video collaboration applications that work on the HMT-1, and there are certainly differences between them, but it's hard to give a kind of overall answer. There are many, many good ones, but it does depend on what you're trying to achieve.
Okay. So someone asked, how are you solving the voice recognition issues caused by the COVID masks in loud environments? This is a critical issue for this particular customer at this time. I'm
going to see if Kyle has some actual recent experience. I can say from my own experience, one layer of surgical mask does not appear to damage the voice recognition noticeably. But Kyle, do you have any experience that you'd like to share?
I don't have a ton other than that. In my experience wearing a mask and directing the HMT with voice commands alone has not shown me any degradation in responsiveness or anything of the sort. We'd like to know more about your specific use case. If you're using a full face shield or anything a bit more cumbersome than just a surgical mask or fabric mask, we'd like to know about it, and we can help you troubleshoot. We do have Rapid Industrial Designer Prototyper who's done a lot of configuration design for how to wear it with different pieces of equipment. We can work with you to figure out if throat microphones and different types of accessories need to be considered. A lot of options there, but let's have a separate conversation there.
Great. Okay, we'll just take a couple more questions. What is the suitable application or software company? No, I'm sorry. These questions are coming in so fast. Can you recommend any standard platform or software to develop wearable apps in the HMT?
If you want to develop your own wearable app, we still feel that the gold standard is developed in native Android using Android Studio. And there are some software libraries that are now available for license from RealWear to help you get to what we consider to be a best-in-class user experience for things like navigating menus and other things from RealWear, but you don't need to use those. People have used all kinds of software development environments, as I mentioned earlier, to develop apps. You can do HTML5 with voice control. You can do Cordova. You can do Xamarin. You can do Unity. There are others. Developer.realwear.com is your place to start to learn about that, or the RealWear Academy. But if you have an open choice, we would always recommend, or I assume our CTO, Chris Parkinson, would always recommend native Android Studio is where you get the most power to use the advanced features of the HMT-1 inside your application. But many examples using many different development environments have been successful.
Okay, and I think the last one, is the HMT-1 already available in China? And is there an export restriction of HMT-1 to China?
Yes, we have been selling the HMT-1 in China for over 3 years, and there is no export restriction. And we have some fantastic customer references in China, including the State Grid of China, which is the world's largest electric utility with over 1 million employees. Unfortunately, we don't have 1 million HMT-1s in service, but we hope that that will grow. And China National Oil Corporation and many others, many other large state-owned and international Chinese organizations. Western car companies like Volkswagen and BMW are also using HMT-1 in their operations in China. So we have a whole legal subsidiary, RealWear China, and a China team that we can connect you with afterwards if you're interested.
Right. I think someone's asking also about India, which you want to answer that, and then we'll conclude the Q&A session after that, because there's lots of great ones. We'll follow up and answer all the other ones after.
Yeah, we'll try and answer these after the session. But yes, we have a significant team in India, a local sales operation in India, no export restrictions there either. Again, some great customer references there, like RVUNL, which is a state-owned energy utility in Rajasthan, which is deployed at scale, and others. So yes, we'd love to work with you in India too. Globally, RealWear is available globally. Except North Korea, Iraq, Iran, and a couple other places like that, pretty much globally.
Right. I think we're in about 80 countries, so very large network. All right, so I think that concludes our Q&A session. We have lots of other great questions that we've either answered throughout this chat or we will answer afterwards. We will email you, just as a reminder, a copy of the study. We will feel free to take anyone who wants to request a demo. So thank you so much for your participation, and we look forward to following up with you.
Thank you all.
Thanks so much.